Hi Year 9s. Went in over the weekend and looked through your SciPads. There's lots of you that have done really well and answered questions well and finished most of the stuff I've asked you to do. There's some of you that have got a bit of work to do, so you know who you are, so I'm not going to tell you now, but I did make a list of who'd done what. I've ticked your answers, and I've put comments in some of your books. But if you know you're someone that needs to catch up, please do that, and please ask me for help on the either Google chat or an email, or do a video chat anytime during your lesson time. Okay? Also ask each other, because you can help each other a lot. Okay? If there's someone next to you that you know has answered a question and understood it, please don't copy them, ask them. And if someone asks you to copy your answers, please do me a favour and help them and say, well, actually, this is why I knew the answer. Okay? Because that'll help you as well. If you have to explain something to someone else, that actually is hugely helpful to your own learning. It helps you remember stuff more. It's true. Okay, so in a minute you're going to see 2 more videos of me. Okay, you should have watched one already, a YouTube video. You're going to watch 2 more videos of me now. One is in here doing an experiment with a conical flask, which is about convection, and that's related to page 73. And then there's a video of me in the lab doing the experiment on page 70. The experiment on page 70 is getting those little those purple crystals that we got the other day called potassium permanganate. And I know it's a long word and you don't need to worry, it's just those really intensely purple crystals that even a tiny bit made everything go purple, yeah? I get a little bit of crystal, put it in a beaker and heat the edge of the Bunsen burner and watch the process of convection. Okay, so I'm not going to talk about that now because you're going to watch those videos in a second, but this is what I want you to do. Watch the video of me in the lab, that will help you answer page 70. The video in here of me talking and the YouTube clip I've attached will help you answer page 73. You're going to then, once you've done that, don't worry about any other pages if I've not said, okay? So don't worry about page 71, don't worry about 72, and don't worry about 74. Okay, so 71, 72, 74, don't have to worry about. But you could cut that thing out on page 71, okay? On page 71, there's like a twirly spiral thing that if you take that home and get it and hang it above a candle, put it above a heater, making sure if you put it above a candle, you don't set fire to it. It's really cool to watch it spin around, okay? And it'll just keep spinning. So take that home, I would, and do it at home. So you're going to do that, you're going to do that. When you're finished, you're going to do your end of chapter review questions. That includes the crossword. Crossword on page 76. Don't worry about page 77, do page 78 and 79. Once you've done that, online SciPad, all the activities and the online SciPad test. I know some of you have done it. I think I saw Jack and Cooper and someone else. I can't remember. I'll show you right now. So, are we still filming? Good. Okay, I can see all of that. So yeah, Cooper, Caleb, and Jack. Guys, have a go, redo it, try and get 100%. I'd like to see you all having done that, and then lots of green ticks here. I know sometimes the green ticks don't show up even if you've done it. I am aware of that, but try and get the test done. If you finish all of that, by the way, this is 2 lessons worth. So this is today's lesson and tomorrow's lesson. I'm not expecting you to do all this in one lesson. Then you're going to do a poster on the topic. That's if you finish everything else. If you finish everything else, I want to see that you have. So I need to see the ticks on the online SciPad, and I would like you, and I don't think this is beyond you technology-wise, to take a picture of the pages in your SciPad of the online end of chapter review questions so I can see that you've done it, okay? So if you haven't got a camera or you don't know how to do that, then you know there's people in your class that will know how to do it and they can just take a picture for you. Don't want you to move on without having done all the bits. And I want to see that you've done the bits, especially on the online SciPad. So once you've done your end of chapter review questions and this, and you're totally finished and you want to move on to the poster, send me a photograph of your end of chapter review question pages and I'll see that you've done that online. Then you can do a poster. What's your poster going to be on? it's going to be using the subtitles on page 77, and you can either choose one. So one says states of matter, conduction, diffusion, convection, changing states. Choose one and do a poster on one, or do a poster of all of them. Make it colourful, draw lots of nice pictures of particles moving around. Make it so that like somebody that knows nothing about the matter topic could look at your poster and get an idea of what you've been learning. That would be good. All right? Any questions, ask me. I'm online for both of the lessons, remember. All right, guys, good luck. Oh, I'm getting my glasses on. So it says, I've done everything apart from point number 7, where it says, light the Bunsen and slide it under the tripod so that you are only heating the outside of the beaker where the crystal is. So I'm going to put it on this side. Okay. Now what we should notice happening, hopefully once the condensation goes off the beaker, is that the potassium permanganate has risen. So it was just in the bottom corner, but it's rising up. And that is because we've heated the potassium permanganate particles. And when we've heated them, remember the space between them gets further apart. And if the space between them gets further apart, it means that they become less dense. And if they're less dense than the water will sink under them and they will rise up. So if something's less dense, it will rise. So it's risen. And then what we'll notice is once they get to the top here, they'll cool down. And when they cool down, they'll contract again and the particles will get closer together. And when that's happening, it'll sink. And what we'll see happening here is called a convection current. So when it's heated, the particles move away from each other. That means it becomes less dense and it rises. And then when it gets to the top, they cool down because the heat's not at the top. And when it cools down, it will sink again. So now it just looks like the whole thing's purple. But if we did this and we kept watching like an individual particle, we'd see it going up and down and up and down. I'll try and get a better YouTube video where someone's done a better job than me. But there you go. I might have shown you this in class a few weeks ago and I actually can't remember because it could have been with the year 10s. I can't remember, okay? But what I'm going to do is show you, if you've watched that video on convection, the YouTube one that I just told you about, you should have an idea of what's going on now. If I put some food colouring in here, okay, the food colouring is only to show the movement of hot water in this experiment. So I've put some food colouring in here. I feel like I've just got blue on my head. No, I haven't. And then I'm going to top it up with hot water. And then I'm going to submerge it in this conical flask which has cold water in it. So let's pour it in. This is hot water. You can probably see it steaming a bit. I'll just try and mix it a bit more. And I'm now going to lower it into the cold water. Okay, here we go. And what you'll observe is the hot water, which is blue, is rising higher than the cold water, which is normal watercolour, and that is because the hot water is less dense. That means the particles are less close together. And if they're less dense, it means that they're going to move higher. They're going to rise up above the rest of the particles, which are more dense. So if you could draw particles and represent this happening, you'd make the blue ones more spaced out and the normal water particles closer together. Now, once those hot particles rise up because they're less dense, they're actually going to cool down. And when they cool down, they're going to contract again and get closer together, and they're going to get more dense. And if they're going to get more dense, it means they're going to sink. So you see they're starting to sink again. So they're going up when they're warm, they cool down, and they sink. Now, if that carries on, it's called a convection current, okay? And that is how you can describe how heat moves around in liquids and in normal air. So if this was a room, like the YouTube video, a room, and you had the fire on, the air particles around the fire would rise up to the ceiling, and then they'd cool down, and then they would move around the room.